In this video, we're going to talk about transformations a little bit more in depth and talk about the rules or what happens when your variables A, H, and K are specific values. Quick highlight, remember a transformation takes a given shape, object, or function and moves it to a new place. Now, below here, we see that we have A, we have H's, we have K's. Now we have this stuff that's in parentheses. I want to talk about it really quick. So what's in parentheses? Okay, I don't have a spot for it on this multi-flow map. But what it is essentially, it is your, what I'm going to call operator. So the operator is in what kind of function, okay? Now, we have our A values. Okay, so if A is less than 0, you have reflections across your x-axis. Another way to think of this are flips. If the absolute value of A is greater than 1, you have vertical stretches. And if the absolute value of A is less than 1, you have vertical compressions. This will be the hardest of the transformations in my opinion. I remember stretches as getting skinny and compressions becoming wide or flat. The next value is H. And what H does, H can either be positive, so bigger than 0, or H can be less than 0. Okay, if H is equal to 0, then there's no horizontal movement. If H is bigger than 0, it's a horizontal shift right. If H is less than 0, say horizontal shift left. Then last but not least, we have K. And K, just like H, can be either positive or negative. If K greater than 0, we have vertical shift up. If K is less than 0, there's a vertical shift down. Okay, now all of these values are variables, so you just have to pick some random values to test. So what I want you to do is go to Desmos or open you up a Desmos after watching this video and complete the visual description of transformation. So just like circle and fill in the blanks, or circle the right word for vertical stretch, vertical compression, horizontal shifts, vertical shifts. I would test a handful of values that fit these restrictions. So if A is less than 0, right, you can pick anything that's less than 0. So like -5, -1, -0.2. Okay. The absolute value of A is greater than 1. So 6, 4, -12. Okay, because remember, absolute value changes it to positive. And then the absolute value of A is less than 1. So I would say A is equal to 0.5, -0.6, and 0.25. Okay, again, pick 3 random values for each of these and see if you can't come up with some rules. Now, the function that I like is the absolute value function. So I'm going to, and you'll just need to type in a function that we've already covered on pages 1 through 3, with the exception of linear. So quadratic works, radical works, cubic, rational, or absolute value. I would suggest either use absolute value or quadratic. I like absolute value just because it's, for my eyes, just a little bit easier to see. So y equals functions right there. Absolute value. The absolute value symbol is above ABC. Y equals absolute value of X. And then you want to type in Y equals A absolute value X minus H then plus K, and you want to select sliders for all. Now, again, we're focusing just on our A values right now. So H is 0 because we don't want to move it left, right. K also 0 because we don't want to move it left, right. We only want to focus on what happens to the graph when our A values adjust. So you can stop it at random places, like here, and I'll say, all right, so at -2.5, how does the graph look? And I would make a note. So because I chose these 3 points up here, I'm going to do a compression for y'all. So I chose 3 points talking about compression. So I said 0.5. Green is what I start with. Purple is my transform graph. And again, right, it gets flatter. It increases slower or decreases slower. I'll then try -0.6. So now it flips, but it's also flatter than what the green graph is. Last but not least is 0.25. And again, right, it's also flatter than the green graph. So these are what compressions look like. And you can change it from function to function, right? I can make this a quadratic if I wanted to. All right, just by putting my parentheses around the x minus h, and then what makes it a quadratic is for that to be squared. Okay, it's flatter. It doesn't increase or decrease quicker than what you're given. Okay, so again, do the rest of this, pick some random values, and then go through and complete the stretches, compressions, horizontal, vertical shifts. Really quick, I want to talk about the horizontal shifts. Now, if you notice here, h is positive, so h is positive 5. So when I plug positive 5 into ax minus h squared, it would be y equals a x minus, and then h, right, is equal to positive 5 plus k. So y'all can see my purple and my orange overlapping. Now say if I thought it was negative 5, okay? So negative 5 would really just be plus 5. Well, that purple graph and orange graph are no longer the same. The reason I say this is this comes back from vertex form in Math 2, right, when we first started looking at these things. Your H value is going to be the opposite of what you think unless you are 100% certain. Okay, I'll say that again. Always choose the opposite of what you think your H value is unless you are 100% sure that your answer is right. So if I had the options of 5, negative 5, right, we teach you to do this. We find a vertex. That's the most important part of doing transformations. We'll cover this tomorrow. But so I get 5, 0. So what's my H value here? Okay. Well, it's not negative 5, right? Because if I plug this in here, right, it would be x minus 5. Negative 5, if I plug in here, will make it x plus 5. So again, just choose the opposite of what you think.